So we have already talked about systems of equations with two variables, and those were linear. We talked about systems of equations with three variables, which were planar, and those, they intersected in either a point or a line, or they didn't intersect at all. And now we're going to be talking about systems of nonlinear equations, and of course these are going to be in two variables. So what does this even mean? So if they're non-parabolic, or they can be circular, or something along those lines. Well, let's just look at this first example. We have a parabola and a line, and we want to see how those two lines intersect. Well, it is possible that this parabola and this line do not intersect, and that would have no solution. It's possible that this parabola and this line can intersect at just one point. That would have one solution. And it's also possible that this line and this parabola could intersect at 2 points, which gives us two solutions. Well, what if we have a circle and a line? What are the different ways those could intersect? Well, they could intersect not at all, or in 1 point, or also in 2 points. So if we have a circle and a line, or even something circular like an oval shape, an ellipse, even a hyperbola, then those could intersect in none, 1, or 2 points. You could also have two circular shapes. In these examples, we have a circle and an ellipse. An ellipse is just another way of saying oval, but it's a very specific type of oval. So you can see in this example, there is no solution. In this example, there is one solution. Here we have two solutions. Here we have 3 solutions, and here we have 4 solutions. So depending on how our graphs intersect, it will tell us how many solutions we're going to have. So when you're going through these, you always want to check your answers, because you may get something that doesn't really work. Let's look at this first example. Solve the system of equations. Well, if you notice, this equation is already solved for y. So we could just substitute it into our other equation for y. We'll have x minus that y equals -1. Well, that y happens to be x squared plus 1. So let's distribute that negative. Now this is a quadratic equation. We need it to be equal to 0, and we also need our x squared term to be first. So I think what I want to do is move all of this to the right. That way this becomes positive. I'll just make it a little bit easier to work with. So I'm going to subtract x, add x squared, and add 1. So on this side I get 0. This is also 0, so I get -x plus x squared. So rewriting this, x squared minus x equals 0. To solve a quadratic, you need to factor it as much as you can. So let's factor an x out. That'll leave me with x minus 1. Set each factor equal to 0. This one's already solved. Add 1 to both sides, and we get x is equal to 1. So remember, we're actually looking for points or ordered pairs where these two equations intersect. So let's go back to our original problem. We know that x is either equal to 0 or it's equal to 1. Well, what if x is equal to 0? Plug it into this equation. 0 minus y equals -1. 0 minus y is -y. Divide by -1, and we get y is equal to 1. So when x is 0, y is 1. Well, what about when x is 1? We can use the same equation. We could use the other equation. It doesn't really matter which one we use. This one just has less stuff to work with. So we'll have 1 minus y equals -1. Subtract 1. -y is equal to -2. Divide by -1, so y is equal to 2. So when x is 1, y is 2. So we think that these are our solutions. We just want to check them to make sure they work. X is 0, y is 1. So I have 0 minus 1 equals negative 1. That works. Here we have 1 equals 0 squared plus 1. Well, 0 squared plus 1 is 1, and that is equal to 1. So this one works. Well, what about 1, 2? X is 1, y is 2. We'll have 1 minus 2 equals negative 1. That works. Here we have 2 equals 1 squared. Well, 1 squared is 1 plus 1 is 2. 2 equals 2. That one also works. So even if you don't write down that you checked it, at least check it. Okay, so how about this one? In this one, y is already solved for. So we could substitute that y into this equation. Now if you'll notice, this is a line, y equals mx plus b. Since we have an x squared and a y squared, this is going to make something circular. Okay, we don't know that it's going to make an exact circle because we haven't studied that, but we do know that it's going to be circular in fashion. So let's substitute that 3x minus 5 in for y here. Now be really careful. 3x minus 5 all squared means 3x minus 5 times 3x minus 5, right? So this works out to be 9x squared minus 15x minus 15x plus 25. So that would be 9x squared minus 30x plus 25. Now you want to be careful. If this had been a minus right here, you would need to have this in parentheses because you need to subtract the whole thing. But since it's a plus, we can continue on as it is. So combine like terms. This is quadratic, so it does need to be equal to 0. That will give us 10x squared minus 30x. I'll go ahead and subtract 5 as well. And that would give us plus 20 equals 0. Now at this point, you could actually divide both sides by 10, and it'll make it a little bit easier for you. So we end up with x squared minus 3x plus 2 equals 0. We can factor this. We need factors of 2 that add up to negative 3. That'll be a negative 1 and a negative 2. Set them both equal to 0 and solve. Now we have two values for x at this point. We can go back to our original problem. The easiest equation to substitute them back into is this linear equation. So when x is equal to 1, what happens? Well, we have y is equal to 3 times 1 minus 5. 3 times 1 is 3. 3 minus 5 is negative 2. So when x is 1, y is negative 2. Now we also have when x is equal to 2. So y is equal to 3 times 2 minus 5. So that's 6 minus 5 or 1. So when x is 2, y is 1. And of course, you should go back and check these to make sure. 1 squared is 1. Negative 2 squared is 4. 1 plus 4 is 5. That works. We'll have negative 2 equals 3 times 1 is 3. 3 minus 5 is negative 2, and that is equal to negative 2. So this one works. Try this one. X is 2, y is 1. So we have 2 squared is 4. 1 squared is 1. 4 plus 1 is 5. That works. This is 1. 3 times 2 is 6. 6 minus 5 is 1. 1 equals 1. This one works. Okay, we also have this equation, or this system of equations. Both of these are circular in fashion. Now you'll notice, let me go back to the original, or the last problem. If we were to put the 3x on this side, we would have a negative 3x plus y equals negative 5. We couldn't use elimination because this one has an x, this one has an x squared, this one has a y, this one has a y squared. So our variables aren't the same. But on this one, our variables are the same. So we actually could use elimination on this problem. We can multiply this first one by a negative 3. And that will make our x squares cancel. So we'll have a negative 3x squared minus 3y squared equals 26 times 3 is 78. So a negative 78. Okay. Add them together. Negative 3 plus 25 is what? 22. And 100 minus 78 is also 22. Divide by 22. And we end up with y squared is equal to 1. When we take the square root of both sides, don't forget plus or minus, we end up with y is equal to plus or minus 1, which is the square root of 1. So then how do we find out what x is? Well, we have these two cases. When y is 1, we need to figure out what happens. And when y is negative 1, we need to figure out what happens. So let's use that first equation. We have x squared plus 1 squared equals 26. 1 squared is 1. Subtract 1. So x squared is 25. Take the square root of both sides. Don't forget plus or minus. So x is equal to plus or minus 5. Well, look what we have. X is 5. Y is 1. X is negative 5. Y is 1. So far, we already have two solutions, and we haven't even done the second half, right? So plug in negative 1 for y. We'll have x squared plus negative 1 squared equals 26. Well, when you square negative 1, you also get a positive 1. So this is actually just like the one before, right? You could stop here. If you wanted to, you could stop there. You could also just keep going to finish showing your work. We know that x is equal to plus or minus 5. So in this case, x is 5, y is negative 1. X is negative 5, y is negative 1. Supposedly, we have 4 solutions for this particular system. I want to show you what this looks like in graph form. Let me see if I can get all this graphed for you here. So whenever you graph something circular, you have to do 2 parts, the upper part and the lower part, or you can do the right side and the left side. So you don't have to know how to do this. I just want you to see what it looks like. Hopefully I'm getting all that in there correctly. And the other one is, oh, that was the last problem. Sorry about that. Okay, that's the first equation, and then we have the second equation, which is a little bit longer. Hopefully I can get all that in there. I'll just make sure. Negative square root of 100 minus 3x squared all over 5. I think all that's right. Let's just sketch the graph and see what happens. upper half of the first one, lower half of the first one, upper half of the second one, and lower half of the second one. Looks like a hamburger. Can you tell I'm hungry? Alright, so you can see we do have 4 solutions. And 1, 2, 3, 4, 5. It does look like it's at negative 5, 1, negative 5, negative 1, 5, 1, and 5, negative 1.